Hello friends, welcome to Ansys-Tutor. In this video, we are going to analyze fluid flow and heat transfer analysis on a heated cylinder. On this heated cylinder, there are two imposed inlets airflow which is at 45-degree angle. So, it is a heated circular cylinder which is maintained at temperature of 310 Kelvin and it is placed inside a square chamber. Air is entering to the chamber. We need to find out what is the heat transfer from this. This is the square cylinder. There are two inlets, one is at the top and one is at the bottom. Air is entering at 45-degree angle at the top and 45-degree angle at the bottom. We can see two black color arrow marks showing the resultant velocity directions. So, the velocity, inlet velocity is divided in components form. It is like this: x velocity is equal to x cos theta, that is the angle which is 45-degree, and y velocity as y sin theta. We need to impose these velocities as components form in the inlet. At the top inlet section, the velocity is along a negative y direction. So, we have taken y velocity is equal to minus y sin theta. And in the bottom inlet, we have taken the y velocity as usual as positive sin y sin theta. We need to find out how to do these setups of these velocities and get the resultant output from this. Start creating the geometry in ANSYS Design Modeler. Select the units as millimeter, go to sketching and draw a rectangle with origin at the center. Now draw a circle at the origin, center at the origin. Now go to constants and impose symmetry boundary conditions to all these horizontal and vertical lines. Now go to dimensions and put all the dimensions. Take the horizontal as 400 mm and vertical line as side as 400 mm and the circle diameter as 150 mm. Now click on generate. So, we are going to convert this sketch into 2D body, 2D surface body. Go to concept tab and select surface from sketches. Select this sketch and click on generate. Now, this is the 2D surface body. Now we want to create the inlets and the outlets on this. For this we are going to go to modify toolbar, and select split option. Now select the point where we want to put the inlet and outlet. Now again go to constraints and put symmetric boundary conditions on these two inlets, so that it would be symmetric about this origin. Now put the dimensions of this inlet and outlets. Put the inlet as 50 mm, both inlet as 50 mm, outlet is 150 mm. Now geometry is complete. Now we are going to prepare the geometry for this meshing option. For this we are going to insert another sketch on this xy plane. Now go to sketching, select a rectangle around this circle and put the dimension so that it would be a square. Now put symmetry boundary condition over here. Similarly select the x axis and two horizontal lines. Now put the dimensions. Now put the value of dimensions. Now go to draw toolbar and select line option. Join the smaller square to the outer square through a single line. Join all these lines. Now we are going to split this surface, 2D surface, using these lines. So select face split option. Select the surface as target face. Now select all these lines of the sketches. Now the side of the square and all these 4 lines. And click on apply. Now click on generate. Now you can see the face has been splitted. This would be helpful for us in the meshing stage. Now close this one and proceed for meshing. Tell the mesh to sizing and turn on the adaptive sizing option. Increase the resolution up to 7. Now insert a sizing option. Select all these lines, inclined lines. Click on apply. In the type, select the number of divisions option. Enter the number of divisions as 20. Select the behavior as hard and add bias setting. Enter the bias factor as 5 and bias type should be increasing towards the center. Now insert sizing option. Select all these sides of this square, then click on apply. Select the type as number of divisions and enter the number of divisions as 50. Select the behavior as hard. Now select face meshing option. Select all these faces, splitted faces, and click on apply. Go to meshing and select generate mesh. Meshing has been done successfully. Now we are going to create the name selection for the all boundary surfaces. Select the inlet one. Right click and select create name selection. Name it as inlet 1. Similarly select the second inlet and name it as inlet 2. Click on OK. Select the outlet and name it as outlet. Now select this circular cylinder, select the circle name it as cylinder. Let's check all this name selection has been assigned properly or not. Now select all these remaining walls. Right click and name it outer wall. Now meshing is complete. Right click on mesh and select update. The mesh has been linked with the Fluent solver. Now close this meshing. Open the Fluent setup. Click on edit. Select the double precision model and click on start. Go to models, turn on the energy equation, go to viscous model, select the laminar model for simplicity. Now turn on the energy equation, click on OK. And I have selected air as the default material for here. For this case, you can change your material as per your requirement. In the shell zone condition, we need to assign the material which you are going to use. Select the material name and click on apply, then close. Now go to boundary conditions. Group the boundary conditions. Select the inlet. Inlet 1. Click on edit. Now we are going to put the velocity options as components form over here. For that, select the velocity specification method as components, and in the x velocity select the expression option. Now we are going to write down the velocity in components form. Our maximum velocity is 0.007, so I have written 007, then cos theta. Angle, case the angle is 45 degrees, so I have taken cos pi by 4. As in Fluent, all the inputs are in radians, so you need to put like that. After entering, click on refresh this value so that you can check the expression is correct or not. You can click on OK. Similarly, enter the y velocity, select the expression option and put all this value with changes only. In place of cos, you need to write sin theta. And as it is along the negative y direction, so we are putting the negative sign over here. And click on OK. Click on apply, then close. We are maintaining temperature of 300 Kelvin for inlet 1. Similarly, we are going to assign the velocity in the inlet 2. Select the edit option. Select the velocity specification method as components, and in x velocity select the expression option and click on the effects. Click on the effects to write down the expression. The same expression as before, only changes in y. In this case, we are going to use positive y velocity. So that's why I have only selected the same function with positive y and click on apply, then close. And now we are going to put the boundary condition, heated boundary condition on the cylinder wall. So select the cylinder, click on edit, go to thermal tab, select temperature option and enter the temperature of 310 Kelvin. Click on apply, then close. Now in the outer walls we are going to put the adiabatic wall condition. For that we are going to put the heat flux is equal to 0 for all the outer walls. Click on apply, then close. Now all the boundary condition has been assigned successfully. Now going to methods. Select the green Gauss cell based method. With all second order pressure, momentum and energy special discretization. Now go to monitors, select residuals and decrease the residuals up to 10 to the power minus 30, so that it would take more time and more accurate result would be obtained. Now go to initialization and do the hybrid initialization. Now go to run calculation page and put the number of iterations as 1000. Then click on calculate. It will take some time. Calculation is complete. Click on OK. Now close the Fluent and proceed for save the post processing results. Open the results. Insert a new streamline. It should be 3D streamline. Then select the inlet and click on apply. Here you can see the flow path through this inlet 1. Similarly, let's see the flow path in inlet 2. Is like this. This is the two inlets and flow through these two inlets. You can see the flow is directing towards the cylinder, which is at 45 degree. If you can increase this number of points, you can see this more number of streamlines over here. Select this camera icon to save this image. Select the white background, image quality and the path where you want to save this image. Now we can see the animations over here on the streamlines. You can see surface streamlines. Select the surface as symmetry 1. Now insert a new contour. Select the variable as location as symmetry 1 and variable as velocity. And the number of contours as 100, then click on apply. This is the velocity variations. You can save this image. Go to different legend view to change the appearance of this legend bar. Now let's see temperature variations. This is the variation of temperature. Now turn off the contours and insert a new vector. Location as inlet 1 and inlet 2 and outlet, and click on apply. Here you can see the velocity direction. If you are increasing this size, you can see clearly. Now go to symbols and increase the symbol size to see it clearly. Here you can see velocity direction. With this, let's conclude this demonstration. Hope you have liked this video. Subscribe to our channel if you are new. Thank you. Keep learning and keep exploring.